Hello everyone, my name is Abhishek and welcome back to my channel. Today we are at day 6 of Observability Zero to Hero series. Till now we have completed 5 episodes in this series where we learned about two pillars of observability, metrics as well as logs. In today's video, we will learn about distributed tracing, which is the third pillar of observability using Jaeger. In this video, we will learn what exactly is Jaeger, what is its architecture. Then we will also learn more about tracing, how would it help developers, DevOps engineers, SRE engineers. Then we will see how to install and set up Jaeger on a Kubernetes cluster using Helm. We will also see how developers instrument tracing. I'm going to share you the complete code using OpenTelemetry, how developers can instrument the tracing in their applications. And finally, we will also look at the demo. So by deploying a demo application, we will see how to view and analyze traces on the Jaeger UI. And we will also cover the cleanup and complete uninstallation of Jaeger as well as the cluster. So this video is going to be theoretical as well as practical. And I'm sure after watching this video, you will get a clear understanding of distributed tracing. So make sure you watch this video till the end. And after watching this video, I would highly recommend you to go through this GitHub repository. And if you go to the Day-6 folder, you will get the complete notes. And the reason why I'm asking you to go through the notes is because we have taken utmost care in preparing these notes along with the architecture diagram, commands that we have used, that we will be using in the video, and the manifest files as well. Everything is shared in the repository. We have taken a lot of time to prepare these notes. So make sure you use it as your revision purpose. Okay, now let's move to the whiteboard and let's understand tracing. In the previous classes, we learned that there are three pillars of observability: metrics, logs, and traces. We already learned about metrics and logs. Now let's understand what is traces or tracing. I will start with a real world example. Let's say you are in Hyderabad, India, and you have a friend who frequently travels between Hyderabad and Boston in the United States. And this time, your friend invited you to their house in Boston. And you have never traveled to Boston before. So, the very first thing that you do is you prepare a travel itinerary, that is, how to reach from Hyderabad to Boston. And you research on the internet, you identify that, okay, first you need to go from your house, you need to take a cab and reach the Hyderabad International Airport. And from there, you take a flight to Dubai or Abu Dhabi or maybe London. And from there, you take another flight to Boston in United States. And from the Boston airport, you take a cab to reach to your friend's house in Boston. So this is your travel itinerary. And because this is your first time, you started noting the time that is taken between each point. That is, from Hyderabad airport, it took you 45 minutes to reach the Hyderabad airport. And to reach Dubai, it took, let's say, 3.5 hours. And this long flight, assume it took 12 hours for you. And the cab took 2.5 hours. And the overall journey, let's say it took some 25 hours for you. And you shared this entire thing with your friend after you reached the house, and your friend said, oh, it took 2 hours more for you. That is, generally when I travel, it only used to take 23 hours, but in your case, it took 25 hours. Now your friend decided to trace, identify what went wrong. So you shared your travel itinerary, you shared the time between the points, and your friend noticed that the cab that you have taken from the Boston airport to his house in Boston should only take 30 minutes, but it took 2.5 hours for you. And that's where your friend realized that, okay, you have taken a wrong cab, because of which there was 2 hours delay in your complete journey. So, how are you able to trace the issue? Because of the travel itinerary and the timings that you have noted. Now, you can relate the same thing into the world of where software engineering, where in the world of microservices, let's say you are working for a e-commerce application or you are developing a e-commerce application, and there is the login service which has to talk to the payment service. So in the world of microservices, that is, as a user, when you want to talk to the payment service, your request went to the login service where you are authenticated and authorized. From there, your request went to, let's say, a service called service A. And from there, it went to service called service B. And from there, it went to the payment service. So you finally reach to the payment service, but your request went through multiple hops or multiple microservices. In the world of microservices, it is common that your request might travel through multiple services. There can be multiple hops. It can be network appliances. It can be load balancers. It can be the proxies. There can be multiple things in between. Now, how would you identify? Let's say this request has to take 1 second, but somehow this request of user to reach the payment service through the login service is taking 4 seconds. Now, how do you identify what is creating this latency or what is creating this delay of 3 seconds, which is very, very costly if you are dealing with e-commerce applications or banking applications, anything. So for that, you need tracing. Just like how the travel itinerary along with the timestamps helped you in the world of software engineering, in the world of microservices, you need something called tracing, which is exactly similar to this. So your tracing should provide what are the different services or what are the different hops that were involved in the communication, because to the end user only knows that he or she wants to communicate to the payment service. But if the tracing is available, the end users or the DevOps engineers or the SRE engineers or the developers can understand the request first went to the login, then it went to the service A, then it went to service B, and finally it went to payments. Where from service B to the payments, the ideal time was, let's say, 30 microseconds, but it took 60 microseconds. So now you will start debugging, you will start troubleshooting, or you will tell your developer that, okay, so using tracing, I have identified, that is, as a DevOps engineer, you will tell your development team or you will create a issue with them that the 30 microseconds, which is the expected time, is not meeting the expectations. Now it is taking 60 microseconds. Please go ahead and investigate what is the problem. So all this is possible only if you have implemented tracing in your applications. Now, how do you implement tracing? This is important thing, right? Okay. Abhishek, I understood what is tracing. So tracing is basically identifying or understanding the route, understanding time taken between each hops of my request. Okay, I got it. But how to implement tracing? Like if I give you a application from GitHub, does it come with tracing? No. So to implement tracing, there are two parts. So the first part is the developer of the application or the developers of the application. They have to do the instrumentation, that is in their application. Don't worry, I'm also going to show you how instrumentation will take place. I'm going to give you the complete code of the application so that you can also try it at your end. So developers have to do the instrumentation, just like within the application, how developers instrument the metrics, how developers instrument the logs. Similarly, developers should also instrument the traces. Now it depends. There are multiple programming languages. Each programming language has some modules, plugins, libraries, but a preferred standard is to use OpenTelemetry. So OpenTelemetry is gaining significance and it is vendor neutral as well. Tomorrow, if you want to move from one tracing tool to the other tracing tool, it would be easy. So people these days use OpenTelemetry as standard. But a point to note, there are multiple other libraries, there are multiple other modules which can help you write tracing in your application. So what developers do is they instrument tracing. For example, if you go to the day 4 folder where we have a test application or demo application, you can see in the application folder, if you go to service A, there is a file called tracing.js. And here, using the OpenTelemetry libraries within this application, we have instrumented the tracing. And similarly, in service B as well, you can see there is a file called tracing.js, and using which we have instrumented the tracing in this application. Now, tracing can be even more deep. That is, not only from service to service, you can also define instrumentation, or you can define tracing at the function level. So you can understand from which function of a service the application routed to another function, from there it went to another service. So it's up to you how much level of tracing you want to implement. So this part belongs to the developers. Then there is other part, that is DevOps engineers and SRE engineers. The responsibility of the DevOps engineers and SRE engineers is to implement the tracing. Implement in the sense, so they need to deploy the tracing related tools. For example, in this video, we are using Jaeger, which is a open source distributed tracing tool. So, but there are multiple other things, not only Jaeger. You can use Datadog, you can use Dynatrace. There are multiple applications these days in the market, but a popular one is Jaeger, which is very lightweight, very simple. If you have a startup, I would recommend to start with Jaeger. Even if you are working in an MNC and you have to implement the tracing, start with Jaeger. It is very simple. UI is also very minimalistic. It will not confuse you. So the DevOps engineers, they set up the Kubernetes clusters, they set up the required configuration and install and configure Jaeger. So only if both of these things are done, you can implement distributed tracing. If one of these things is not there, let's say you have, as a DevOps engineer, site reliability engineer, you have created a Kubernetes cluster, you have installed Jaeger using Helm chart, and you have created other configuration, which I'm going to cover in next 5-10 minutes. And the developers of your organization did not instrument the traces. There is no point. Of course, you can get some very minimal tracing because these days the tools are also very capable. They can get through some sensors, eBPF sensors, but that information is minimalistic. You cannot compare that with the tracing that comes with the instrumentation by the developers. Okay, so this part is clear. Now, how does Jaeger actually work? Now, this is very interesting. So if you have followed the previous classes, where let's take example of Prometheus. The interesting part is that whether it is Prometheus or it's Elasticsearch or the EFK stack that we have learned or Jaeger, all of them kind of have similar architecture. So if you know one of these architecture, it becomes very simple for you to understand. Let's say you know the Prometheus architecture, it is easy for you to understand EFK and Jaeger. Let's see why. So when we were learning about Prometheus, I told you that in Prometheus, you have exporters and what these exporters do. So they are deployed as the daemon sets and they extract the information from the Kubernetes nodes. If you take node exporter as an example, so the exporter is the one that is basically getting the information from nodes of your Kubernetes cluster. It can be the CPU utilization, memory, disk utilization. Exporter is getting it. And exporter keeps this information at a particular API endpoint. Who scrapes this information? Prometheus scrapes this information. And what Prometheus does? It saves this information in a time series database. And then using the Prometheus UI or using the PromQL, you fire a PromQL query to the Prometheus, to the HTTP server of Prometheus, and it gets this information from the time series database, retrieves it, and gives it back to the user or displays that on the user interface. Exact same architecture in terms of EFK stack as well. You have, whether you have logstash or you have the fluent bit. Let's take fluent bit. So what fluent bit does is it works as an exporter similar to the Prometheus node exporter. So it gets the information from your applications, it keeps the information with it, and it forwards the information. In the world of Prometheus, Prometheus is scraping it. Basically, it's a pull mechanism. In EFK stack, you have the same architecture, but here the fluent bit is forwarding. So it is a push mechanism. Where does it forward? It forwards that to Elasticsearch. And in Elasticsearch, you have something called ElasticDB or the Elasticsearch DB. And whenever a user wants to get the information, so using the Kibana or using the user interface, again, they fire the Kibana query and the query is again executed against the database and database gives this information back to the user. Same with Jaeger as well. In Jaeger, you have 4 components. So the first component is basically the agent, where agent is the one that gets the traces from the application. And point to be noted, agent can only get the traces if the developers have instrumented the tracing in their application. And then you have something called as collector. Now, what does the collector do? Collector collects this information, right? Agent gets the information and collector keeps the information with it. And then you have a database. So Jaeger or Jaeger, it is not opinionated. You can use your own database. For example, you can use Elasticsearch. So by default, it does not come with a database. You need to configure. I'm going to show you how. So the collected information can be stored in the Elasticsearch database, or you can use Cassandra DB. Multiple things are supported. Elasticsearch is a preferred option. It is also very fast. And finally, you have the user interface, where with the user interface, you fire a query to the collector. It gets the information through the Elasticsearch DB and displays it to the user. Now, the same thing is also mentioned in the notes. If you go to the Day-6 and if you go to the day README file, you can see there is an agent that collects the traces from your application. Then there is collector, receive traces from the agent and processes them. Then you can fire a query through the UI, and storage, as I explained, you can use databases like Elasticsearch or Cassandra DB, multiple things. So the architecture is pretty simple. And now that we have learned about metrics, we have learned about logs, and we have learned about traces, you can go ahead and look at this complete architecture of observability. I'm sure if you have followed all the classes, you will understand this. So, I have clearly mentioned in this architecture diagram about the complete observability. You have Prometheus for metrics, you have Alert Manager for alerting, and the architecture is very simple. You have node exporter that is running, Fluent bit that is running, and Jaeger agent. So as I explained here, Prometheus exporters are running on the cluster, Fluent bit is running on the cluster, and Jaeger, the agent of the Jaeger, is also running on the cluster. So overall, when you implement observability using the stack that we have used, you have three different utilities or applications that are running, which is taking the responsibility of collecting the information. One is your exporters of Prometheus, which is collecting the metrics information, running as pods on your cluster. Then you have the Fluent bit, which is collecting the logs. And finally, you have the Jaeger agent, which is collecting the traces from the applications. And they are deployed on Kubernetes. What they do, the node exporter forwards that information to Prometheus, or Prometheus is scraping that information. Then the Fluent bit is forwarding that information to the Elasticsearch. And here, Jaeger is also available in this architecture diagram. The reason why I did not represent Jaeger separately, because Jaeger stores that data in the Elasticsearch itself. So that's why I did not have Jaeger anywhere here. And from there, users get three interfaces: Grafana for metrics interface, Jaeger query, that is the Jaeger user interface for distributed tracing, and Kibana for the log interface. So at the end of the day, if you are the DevOps engineer or SRE engineer, you are going to share these three URLs with your team. So Grafana URL, share with them. Jaeger URL, share with them. And Kibana URL, also share with them. If you want to implement RBAC, if you want to implement SSO, that's a different thing. But this is what you do. You might be thinking, Abhishek, why there is a EBS volume here? Because when it comes to logs as well as traces, because you are storing that information in a database like Elasticsearch or Cassandra, it is important that you take snapshots of this. So to the Elasticsearch, we use the CSI driver for EBS, and this CSI driver, using the persistent volume claim, it creates a persistent volume, and that persistent volume is attached to the Elasticsearch. You will see all that during the demo as well. Okay, so the architecture is also clear. So now let's go ahead and try to deploy this thing. We will deploy the Jaeger, we will deploy Elasticsearch, and we will deploy sample application to see traces on the Jaeger user interface. Let's start with the Kubernetes cluster. So to save time, I already have the Kubernetes cluster, but without any configuration. If you do if I do kubectl get nodes, so you can see that I have a EKS cluster here. If you want to know the steps, Abhishek, I also want to create the EKS cluster. Don't worry, just go to the day2 folder and go to the README file. You can find the complete steps how to create EKS cluster. Let me increase the font size. So how to create an EKS cluster, how to attach the node groups to it, everything is available in this README file. Okay, now that's the Kubernetes cluster is available. What is our next step? Go to the Day-6 README file and start with the steps here. The first thing that you have to do is you need to have Elasticsearch, because when you try to install Jaeger, at the time of installation of Jaeger itself, you will provide the Elasticsearch password, Elasticsearch URL, so that Jaeger talks to Elasticsearch and stores the information in it. So Elasticsearch is available in the day5 README file. Go there. First, we create a service account. This service account is required to interact with the EBS volume. So where is my terminal? Perfect. So here is my terminal. So what are we doing here? EKSCTL create a service account. Why are we creating this service account? Because the EKS cluster or Elasticsearch is in the EKS cluster, and EBS volume is a complete different one. It is outside the Kubernetes cluster. Two different services of AWS. How do they interact with each other? You need a IAM role. How can a service in Kubernetes use the IAM role? It's not possible. So what you do is you integrate the service account with the IAM role. Let me explain this through a diagram because it is important. So you have a EKS cluster, and within the EKS cluster, let's say you have Elasticsearch. You want to use EBS as a persistent volume. How can this Elasticsearch pod within the EKS cluster use the EBS volume? You know, in AWS, if a service wants to communicate with another service, one AWS service to communicate with another AWS service, you need a IAM role. But this is for service to service communication. Your Elasticsearch is a pod inside the EKS. So what you do is, for this Elasticsearch, you create a service account and you tie this service account with the IAM role. Again, how do you do that? You will use the OIDC connector. I have explained this thing practically in the previous classes as well. But for this particular class, this information is enough. How does Elasticsearch use EBS volume? Is using the service account and tying that with the IAM role. So we have created a service account. Now let's get the ARN of that service account. Okay, service account is creating. Perfect. Let's get the ARN of it. So ARN is stored in this variable. Next step is to create EBS CSI driver. Without CSI driver, it is not possible to use the persistent volume as EBS. Okay, there is some network issue. Just give me a second. Let's try again. Cool. So now the CSI driver is also created. Next step is to create a namespace for logging. We will deploy Elasticsearch in the logging namespace. It is better to use different namespaces, even though you are implementing observability. Create a namespace for monitoring, create a namespace for logging, and create a different namespace for tracing so that you can implement different RBAC. It is easy for troubleshooting as well. Okay, it says logging namespace already exists. Then we will use the Helm chart for Elastic. And using this command, we will set up the Elasticsearch. And after you set up Elasticsearch, keep a note of the username and password. It is very important because in the Jaeger, we are going to provide, in the Jaeger configuration, we are going to provide Elastic as username and this one here as password. Cool. So keep a note of this password, or you need to run this command one more time during the Jaeger configuration. Okay. So Elasticsearch is set up. Now let's proceed to day 6 and start with the Jaeger configuration. So along with the Elasticsearch password, we also need to extract the CA certificate for the secure communication. So we will extract the Elasticsearch CA certificate and then let's start with the tracing namespace. So create a namespace for tracing. Then create a config map where you will store the Elasticsearch CA configuration. Because to provide this information to Jaeger, what is the obvious resource in Kubernetes? Config map are secret. This is not that sensitive, so you can use a config map. Cool. Now, what you will do is you will create a secret. So this is a generic secret that you have created. And finally, you will deploy Jaeger. The Helm chart is available. Just run Helm update if required. And finally, run this command. Now, before running this is where in the Helm chart, in the values.yaml, if you go to the values.yaml here, so you need to update the username and password. There are simple, straightforward sections. One is for the collector, one is for the query, that is the user interface, one is for the storage. So this part is for the storage, this part is for query, and this part is for the collector. So we are not modifying anything related collector, and we are not modifying anything related to the user interface. Only thing that we will modify is the storage information. If not Elasticsearch, let's say you want to use Cassandra or something, you can go ahead and change that information here. But for Elasticsearch, the service name will remain the same. The port will remain the same. We are using secure communication. So HTTPS will also remain the same. Only thing that will change is the password. So let's get the password one more time. Base 64. Yeah, I think this is the password. No, this was the username. My bad. Okay. Yeah, I think this is the password. So I will copy this password here. Go to the file called jaegervalues.yaml and just update this password. Without updating the password, please do not start with the Jaeger installation. If you do that, again, you need to modify and run the Helm update. It's not a big problem. So if you have messed up with the password, once you do the Helm install, what you need to do is Helm update. upgrade. Okay, so now Jaeger is getting installed. Perfect. Let's use the Jaeger user interface through the port forward command. So some people were complaining in the comment section that the port forward does not work for them. It's very simple. You might be using EC2 instance. I'm using my laptop. So if you are using EC2 instance, to this command, just add hyphen hyphen address 0.0.0.0, and then you can access the user interface through the IP address colon port. So instead of using this particular thing, that is 127.0.0.1, use the EC2 instance IP address, but you need to add this to the port forward command. Okay, let's try to access this. Okay, it says there is some problem loading. Let's try to see why. Oh, did we stop? Let's run the port forward one more time. And let's access this again. Okay, so the port forward seems to be failing. Let's see what is going wrong. If we do kubectl get pods in the tracing namespace. Okay, so we can see here the Jaeger query pod is in the crash loop backoff. So that means it is not serving the user interface. So that's why your port forward is failing, or when you try to access the user interface, it is sending the request to it and this pod is down. So obviously it cannot. Let's see why is it down. So if we quickly do kubectl describe pod followed by logging, sorry, tracing namespace. Okay, so it says that the liveness probe and readiness probe are failing. Okay, because the liveness probe and readiness probe are failing, the Jaeger user interface is not started. That's why we are not able to access. Cool. Let's see why the readiness probe and liveness probe are failing. Let me debug it. Okay, I just deleted the config map and secret because I think from my previous Elasticsearch instance, the config map and secret were mounted. Let me try again. I deleted that complete thing. So I will run the CA certificate again. And now I have updated the csr.pum. I have also deleted this file. Okay, let's do it again. The tracing namespace, it exists. Good. Let's create the config map from the csr.pem and let's create the secret as well. Perfect. Now I have updated the Jaeger values, so I'm not doing it again. So now let's see if the pods are in running status or not. So all the pods, all the 4 components should be up and running of Jaeger. kubectl get pods hyphen f hyphen n tracing. Perfect. So that was the issue at my end. Uh, I had an Elasticsearch instance before. I deleted the instance, but I forgot to delete its references. That is the config map secret. So when I'm trying to again integrate Jaeger with Elasticsearch, because the liveness probe and readiness probe failed, I immediately understood there should be something issue with the configuration because I use them a lot. And there I realized that, okay, it should be issue with the CA cert file or the certificate. So that's why I deleted the certificate related things, and now all the 4 pods are running. So this is how you need to troubleshoot as well. Cool. So now let's do this again, the port forwarding. If you don't want to do the port forwarding, very simple, go to the service, change the type as load balancer or create an ingress resource for it. Perfect. And let's reload the page. Cool. Now we have the Jaeger user interface. And the reason why I like Jaeger a lot is it does not complicate the tracing. It's very simple. Like if you provide the name of the service and if you provide the operation, that is the get operation or which API call that you are trying to look the tracing for, you will get the complete details. Click on the find traces and you get the complete details. Let's see that. Okay, so what I'm going to do is, of course, we need an application that is instrumented with the tracing, right? So in our GitHub repository, if you go to the day4 folder, you have 2 applications, service A and service B, which are instrumented with tracing using OpenTelemetry. So you don't need to search for these applications on internet. You might find some applications, but they don't have tracing implemented. OpenTelemetry is not available. Instead, just go to the day4 folder. And what you need to do, step 1, create a namespace. Step 2, just run this command. I mean, you need to check out this GitHub repository and go to the day4 folder and run this kubectl apply -k. And in the manifest, right, before you apply, just make sure the deployment files has the right image. So I have my image, you can use my image also. So check out this GitHub repository and run this command. Okay, service A created, deployment created. If you do kubectl get svc in the dev namespace. Okay, so the service A has a load balancer. I mean, it's of a service of type load balancer. So I will access this application and I will run few things on this application. That is, I will run some APIs of this application so that it would be visible in the tracing, right? If you just have the application, it does not show in the Jaeger. Like just search for it. You will not find anything. Like refresh it multiple times. Still the services will be 0 because the agent of the Jaeger, it is still searching for some tracing to find or to find some traces. So what you need to do is take this URL, paste it in the browser. It will take 2 to 3 minutes because AWS has to set up a load balancer for it. So wait for it. And these applications, so they have multiple endpoints, such as there is /healthy endpoint, /server error endpoint, call service B endpoint. So let's use these endpoints and then let's see if it is reflected in the Jaeger or not. That is, if Jaeger can provide me the complete route path or not. Okay, it's still not available yet. As I said, let's wait for 2 to 3 minutes. Perfect. Now the application is running. You can just refresh and see. Let me increase the font size. And as I told you, this application has multiple endpoints. Let's just hit /healthy. Okay, it said Observability series by Abhishek.Veeramalla, status as healthy. This is the application that we have. Okay, now if you go to the Jaeger and refresh, you should see one service. Perfect. So you can see one service and the name of the service is service A because we used OpenTelemetry in that application and we have instrumented the traces. Now in the Jaeger, select the operation like, okay, all the operations because we just have one particular request and when you hit on the find traces, it will show you the complete path. That is how the request that you have hit /healthy, it took 6 spans. Spans are nothing but basically points. So in the example that I told you, Hyderabad to Boston, Hyderabad International Airport is a span. And then Dubai is a span. From there, Boston International Airport, that is a span. So traces are divided into spans. And each span, it tells you that when you hit /healthy, the request first went to the middleware query, then it went to the Express init. So we used Node.js application, right? The Express framework. So it went to the Express init. From there, it went to the logger. From there, it went to an anonymous function. And finally, it reached the healthy endpoint. And when you click on this, like on this particular span, again, you will get the information that how much time did it take. It took 13 microseconds. Okay. And if you want to get information about this span, this one, this one. So if you have implemented the tracing, it will make life of developers easy so that if there are any issues, they can get all of this information. Imagine how useful is it for the developers when you have a request that goes through 10 services. So if a request goes through 10 services, this information will help the developers a lot to identify where there is a latency. Okay, this took 62 microseconds. This took 168 microseconds. So why did it take 168 microseconds? They will go to the code, they will go back, they will try to understand, okay, how can we improve this? Can we make it 100 microseconds in the next release? That can be a story and they can work on it. You can also do another example, like we hit on the /healthy endpoint of service A, right? There is another endpoint in this application where service A will call service B. So this is the typical microservice architecture, right? A service talk to the another service. So I have provided you with that example as well. If you just do call to service B and click on the enter, okay, it said service B called hello from service B. Now if you go back to the Jaeger interface, so you can immediately see number of services became 2. And if you select service B and click on the find traces, you will find that, okay, so the request to service B came from service A with 12 spans. That is like it went through 12 hops or 10 hops. First it went to the middleware, then it went to logger, then it went to anonymous. Then from service A, request went to a function called call to service B. From there, it called the middleware of service B, express init, logger, /hello, endpoint of service B, which returned you the required output. Again, you can click on each of these span and you can share this information with the developer, or if you grant access to your Jaeger to the developer, developers can go through all of this. Imagine how helpful it will be for the developers if you implement tracing in your organizations. Perfect. So this is the importance of tracing. If there is an issue, if there is interviewer might ask you like, what issue did you solve after implementing tracing? So you can give an example that there was a span called express init, or there was a particular function for the express initialization. And when I implemented the complete tracing, there was an issue that service A, service B communication is taking a lot of time. And after I implemented the tracing, I tried to see why it is taking more time. I implemented tracing using Jaeger and I shared this complete information with the developer. So developer could see this information and identify that, okay, maybe the HTTP routing is taking a lot of time. How can I reduce the latency? That way, the DevOps engineering team and development team together, we fix the issue with the latency. So you can explain this way. I hope you found this video informative. Make sure You try this example. It's very, very interesting. And you can also play a lot with the Jaeger user interface. Not only this part, you can also go to the system architecture. You can go to the monitoring part, where in the monitoring part, okay, so it requires the Prometheus time series database, which we haven't integrated yet. But you can get the information such as P99 latency and the other things, right? Thank you so much for watching today's video. See you all in the next one. Take care. Bye bye.